has to be interesting spatially. 2 is it has to be of the time, and 3 is it has to be prototypical. That's what modernism was about. Once you eliminate the prototypical aspect, it doesn't meet my definition of modernism. And out of this house came one of the more extraordinary buildings I did. Is a 1,000-foot long Galleria housing project at the University of Alberta. We call it the longest diner in the West. And from my own little house, in those days I could probably do all the steel detailings on 4 or 5 pages. I would have loved my houses to have been manufactured 70,000 times. I've been perfectly happy, particularly if I had some royalty on it. The next house is the Wolf House, a Toronto house again, which went around the world for me. Condé Nast picked it up and shipped it all over all their magazines. And it was picked as the house that most pointed to the 21st century, and the Wolves still live there. And then Vicki and I found a very beautiful site in Santa Barbara, and we built a new house there. And there's 2 basic ideas here. One is I wanted to go back to the earliest modernists in California that were really concerned about the integration of landscape architecture in the house. You know, California modernism is different from any modernism in the world. In fact, West Coast modernism is different from any modern in the world because we integrate the gardens with the buildings. And so we wanted to do that, really open up. And the other thing is we live in a very dangerous fire area. So the house had to be designed to withstand fire. So I'm using fire shutters and water and non-combustible materials and so these are pictures of the water. I'm using water on the roofs, the way many Persian gardens were done, just for fire protection and water. Clearly steel is the expression of this house. This is my studio. And then the most recent finished house, just finished this year, is a house up in Santa Barbara as well. And it probably pushes the detailing is close to where I'd like it to be at this time. It's all steel, no wood in the house at all. And I'm able to use very beautiful prefabricated panels. So once you can get out of the ground in California, which I must say is very difficult, but once you get out of the ground, the houses go pretty smoothly and pretty fast. I have a faster gun in the West. You can see this one, once you open these doors, there's no distinction between indoors and outdoors. And we Santa Barbarians are very smart. We have the toughest immigration project in America. No bugs are allowed in this part of California. So we're basically a bug-free area. Okay, thank you.
Thank you so much. Thank you so much. Such a range of work, isn't it wonderful? Now, Linda, it's your turn to talk about the It House.
Okay, is this me? So I am going to go through a lot of slides in rapid fire succession to meet the 10-minute goal. And just briefly wanted to introduce the topic of where I started thinking about the It House from Palm Springs. So, of course, Barton has already given us an introduction to kind of history of architecture and the evolution of steel-framed houses. How can you not know, of course, the Kaufman House here in Palm Springs? And the garden idea that Barton already mentioned plays a significant role in the indoor-outdoor life, which is primarily predicated by the use of glass. And so I also just want to introduce the topic of glass in addition to framing. Again, Martin's already talked about the 2 most famous glass houses, the Farnsworth House and the Glass House by Philip Johnson. These are the plans of those houses, which really thought about the idea of, well, if we have this steel frame technology, this post and beam system, which can allow us to open our walls to be completely open to the landscape, we could have the landscape as a painting on our wall. We could have the landscape become a kind of wallpaper on the wall through the use of glass. Now, the It House is really not a steel-framed house. It's actually aluminum. And we found this amazing material that Bosch makes, which is a series of extrusions parts and pieces that were really made for making factory clean rooms. And we made a small structure out of it and realized that the intelligence of the parts made it so you could very, very rapidly put these pieces together. And this is a small sculpture that we built in Basel, where in a number of days with a crew who didn't speak any English, we were able to put this together with 3 people. So we came to the conclusion when we started that we really already knew we wanted to make an aluminum framed house in the same ideals of the steel house with a predominantly glass envelope, where you would take the glass house and then also fold it in the tradition of the California modernist indoor-outdoor living, and have these courtyards that would enable you to have cross ventilation as well as more envelope to enclose the rooms. And the idea of the glass as a kind of wallpaper or painting which gets collapsed onto the interior of the house. And so these are the 3 little axonometrics showing the 3 major components of our house, which is the framing system, and then interior walls are primarily made of cabinet storage walls, and then, of course, the envelope. And the idea of a pattern playing a significant role through the use of graphics that would provide another layer that could also be used for shading. So here's some interior views of the house we built up in Pioneer Town. And just to talk a little bit about the technology, because for me what's interesting about this project is that it's a research into building technology and developing new details and developing systems that can integrate together. So this is the aluminum framing system, which what we like about it is very, very small profiles. These are 3.5 inch by 3.5 inch columns. And they're very elegant, and they have these grooves which enable you to slide in our custom bolted connections, which are then able to be rapidly put together with about 1 tool and 2 people on site. So this is one day, the framing of this house is done. The next day, you can do the steel decking. And it's a very rapid construction on site made with prefabricated parts and panels. So just some details showing the 2 systems coming together. And then the idea of glass as the predominant envelope, and the idea of breaking those panels of glass down to easily assemblable pieces so 2 people could put the entire glass package together. In fact, we have 2 guys who've done most of our houses who travel around California, and they can put together all the glass in a couple of days. And that this again integrates neatly with the system of the aluminum extrusion. Solid walls, we also wanted to innovate the idea of using the aluminum extrusion system that can be really quickly assembled in the field with minimal tools and minimal people, using prefabricated fiber board cement panels. So again, small tools. This is just a little Allen wrench that you use to put those pieces in place. And you put the framing in place, and here you see some of the glass. And then you can insulate between 2 layers of smaller framing members that use the gusset plates. And then you can put these interior fiberboard cement panels, or they can be exterior. And the joints between everything really are exposed. And so everything about the house, we've had to draw detailed shop drawings to show exactly how all of these pieces would come together, but then have it be fairly simple for someone to put together on site. Now, just a bit about the systems of the heating and cooling. If you have an all-glass house, or predominantly, a problem that you have to solve is how do you heat and cool this house? So we have used radiant floor technology, which is much more efficient and makes more sense in a house where you have a thin envelope, as well as the ceiling as a point of distribution. So you can have the technology of the house in terms of electrical, plumbing, heating is all squished into these thin layers of the floor and the roof. So here I am 8 months pregnant, laying down my radiant floor heating. And then in the roof, you can also, in between the steel decking, fit all of your electrical sprinklers, and as well as acoustical insulation. This is just to quickly show these small little ducts that are little white circles. Those are actually small mini ducts for air conditioning in one of the houses. Now I'm showing actually a number of houses when I'm showing these slides. It's not all the same house. And then also being able to integrate solar systems. So this is for our off-grid house that we built in Pioneer Town, where we use the same aluminum extrusion again to make the solar rack that would be installed over the courtyards. And those solar panels double as shading system for the courtyards. And the idea of the pattern again becoming something that helps to mediate the changing seasons. The house is really a bit of a sailboat where you have to, a bit like Barton's house in Toronto, where you have the fabric panels that you can manipulate. This has an interior layer of curtains which you can draw to do different things. This is a large-scale felt wall that we made, and an exterior layer of fabric. So these different layers that you could modulate. And just briefly to touch on kind of new development that we're working on in integrating other systems is just one example of integrating the IT-House system with other technologies, which Lance is actually going to talk about briefly. This system that we have now started using as a kind of hybrid, the Blue Sky platform, that then we build the house, the IT-House on top of, so that you can have decoupling it from the ground and that problem of getting out of the ground. And this is probably what it looks like up in Pioneer Town right now. So, with that.
That's wonderful. Thank you, Linda. Thank you.
Well, Sydney, thank you. And thank you to many of my friends and neighbors who are here today. Okay. I'm pressing, but I'm not up yet. Today, the talk I'm going to give, my 10 minutes, will be on steel construction, prefabricated steel construction, sustainability, and my collaboration with Don Wexler. So it's a lot to take in a very brief time, but I think I'll get through it. To start the talk, when we looked at prefabrication, we looked at the notion that we could, in some ways, emulate the Toyota Motor Corporation or Ford Motor Corporation in the efficiencies of assembly line construction. And other architects have done that, and there's certainly a lot of value in the quality that can be achieved by prefabrication that happens in a factory. And then there's another notion as well, which is prefabrication that happens on the kind of do-it-yourself level. And where we wound up at the end of the day was more of the IKEA idea that you could develop a kit of parts that anybody with a good instruction set, and we saw that with the Sears homes in a previous lecture today. These don't come with 900 pounds of nails or 600 pounds of nails. Rather, there's bolts, and it's a bolted together prefabricated system. And I'll show some ideas on the Blue Sky Home system that we worked with that notion that something could be flat packed, could be delivered to the job site, and then put together with skilled and unskilled craftspeople. The other influences that I have in the upper right-hand corner is just a beautiful end elevation of one of Glenn Murcutt's homes in Australia. And it points up a couple of things, which is architecture is very international. And the idea that somebody working halfway across the world could be influencing somebody who lives and works in Palm Springs it's ubiquitous. It happens every day. Images pop up on our screens. I think back in Don's days, the publications were really good about searching out good and unique work. In Glenn's work, I had the fortune when I was an undergraduate, he came to our studio and spent the day with us. I had an Australian teacher, and this is back in the late 90s. And hadn't really heard of Glenn Murcutt, hadn't really heard of what was going on in Australia, but quickly learned that there were a lot of very innovative things going on. And the notion of touching the earth lightly was something that I carried with me from that day forward. And my own experience growing up here in the Coachella Valley, I had grandfathers who were both ranchers. And so this idea that growing up on something that it's very much dependent upon the environment, the interaction with the environment, water, and recognizing that this is a desert. And that image for me is it's so poignant because the San Andreas Fault's running right back through there, Interstate 10 running from Los Angeles all the way back to New Orleans. This cosmological thinking going on here between row crops and citrus and all the things were all those influences that I had as a young boy. So the Blue Sky Home system and the systems thinking behind this that Linda just spoke about was really how do you develop a kit of parts that can be put together in a way in potentially remote locations, because as we move forward with our building industry and places for folks to live, there's going to be intense pressure to densify our urban environments, and there's going to be this need to also want to get out and celebrate nature. And the only way to really get out and celebrate nature in an enclosed built environment is to do it in a way that's very sympathetic to the site. So this system, because it's a bidirectional moment resisting frame, which is a kind of a technical term to say that it's kind of like a dining room table where all it needs to do is just sit on the ground very lightly, allows us in many different configurations to deal with what I think Barton was alluding to, which is once you get out of the ground. Getting out of the ground with this system is the simplest thing, because it's sitting very lightly on 6 little footings. And then my own house here in Palm Springs, and for some of you who are going to be on the tour today, we're going to visit this today. Unfortunately, it probably won't be this nice sunny day that is shown here in the images. We've lived in it for 2 years now. We have, initially when we started the home, we were in the U.S. Green Building Council's Lead for Homes program. It was a pilot program at the time, and we achieved LEED Platinum with the home. But that was really a way of just kind of quantifying that, yeah, the thinking, the sustainable thinking that we do in my office and that I've carried with me through my life is we can make that sort of objective. And so by having LEED Platinum status, it just says that, okay, this has achieved something. But what it's really achieved for me and my family is we've never had an electric bill. I mean, we get the bill from Edison, but there's never anything over $2 to process it, and we've never had the heat on in the home. So the home is truly sustainable in the sense that even today, when folks walk in it, we've never had the heat on. The home will be 68 degrees or 69 degrees, and it's just because of some sensible thinking about placing the glazing in the southern orientation and shaping the home in and around the site. And the last image I'm going to show today is a collaboration we're currently working on with Dawn in the office. And this is with a very progressive client from New York City wanting to build California modern homes in the Hamptons. And I have an extreme love of steel, and as much as I'd love to say that it's the ideal material all around the world, it is not the ideal material all around the world unless you solve the technical details. And I think that's the things that architects every day in their studios are trying to achieve. With this home, rather than trying to solve the technical detail of steel, and primarily it's the condensation that happens as the steel is exposed to the cold outdoor temperatures, and then that immediate conduction into the interior then forms water condensation. And I'm fortunate to have grown up here in the valley, where I know when I grab a storefront door that's facing west on any store on Palm Canyon, it's going to burn my hand or my steering wheel. And so I have the experience of heat conduction, but I'm also fortunate to have a Swiss architect in my office who knows very intimately what happens when you put steel against a very cold and damp climate. So in working with Dawn, Don and I both sat down and we said, you know what, let's pursue steel on this. And after a couple of quick discussions, we immediately said, you know what, trying to solve all those details when the home and the developer is on the other coast is just going to be more than we want to try to tackle. So this is a true post and beam home, modern in all of its configurations. We really styled this after some of the early thinking Don did in his post and beam homes, and primarily the Donna Shore house. And that's all I have. Thank you.
Thank you to all of you. I think you can all clearly see that all three of these architects have continued the innovations that began so brightly after World War II, and with Don Wexler's design and other modernists in Southern California. And of course, using current technology, which is advancing and changing and making all these building developments possible. So I'm going to address a few questions to each one of them about some of their systems and their architecture. One of the goals of the case study program, and Tom Hines was referring to a number of the houses that were in the program that was initiated by John Intenza for Art and Architecture in 1945. One of those goals was to promote good design for mass housing. We know that Wexler and Harrison's plan for 35 steel homes resulted in 7 being built because of the price of steel changing and some change in management at U.S. Steel. But Barton, you did 77 prefab steel houses in 1977. So what happened? What happened to the whole, what held back the development of more prefab housing after that date?
Well, let me define the terms first, because what you saw from the three of us is really component building. None of us are setting up factories to turn out thousands and thousands of these houses to be supplied. So we're still at the component, I call it catalog housing. You can select the pieces and parts and put them together. Now, I think the case studies is one of the greatest experiments in modern architecture in California. And it has implications worldwide, but did not really affect manufactured housing. So when I say manufactured housing is that you set up a plant, you fabricate it in the plant, and you ship it out, and you as totally built and put it on the site. Not what you've seen here is where we send pieces out and then we erect them on the site. I think the case studies never had a clear vision of how you would go from their ideas into the next step of the manufactured home. And it's interesting to see the early case studies are really fascinating because they were all wood builders. They were post and beam architects. And they never wanted to lose the stick idea. So both of you guys are still in the stick kind of tradition. That's 2 people can build these houses. And that's what all those early guys in the case studies wanted to do. But case study 22, Corning comes on and really uses steel in the way I think it should be used for big scales. You don't want to use steel when you're only spending 10 feet. Wood will do it just as easily. There are other ways to do that, other composite ways to do it. So case study 22 is kind of revolutionary that it's large span. But the problem with the case studies to me were they were such exotic buildings and so exotically sited that no one really could see the prefabrication possibilities of it. Now I did study after study when operational breakthrough, when HUD tried to stimulate prefabrication in the United States in the 60s, late 60s and 70s, and I'm sure that Wexler was probably responding to those programs. But the idea of doing manufactured housing, we did studies for Alcan, we did studies for plywood companies, and the rub in the whole equation is unless you have service land ready to receive the product, it just doesn't work. Unlike the automotive industry where we built the roads, and as long as you're willing to sit in a parking lot and buy cars, they'll sell them to you. In housing, it doesn't work that way. Unless you can figure out what your production is going to be and you can move it quickly to a service lot and get it up, you just can't warehouse it all the time. Now, we came pretty close. In Canada, we're more adventurous than the United States, and the government will take more innovations of doing land banking, getting it serviced so we could begin to predict at least a reasonable supply of land that could receive these homes. But that's the rub. The ones I did for, at Hamilton, Ontario were sponsored by a similar program to HUD. They were heavily financed by the Canadian government. We had land already available for it, and it was pretty exciting. It really was truly seeing my houses coming down one production line and seeing locomotive and trains coming down the other one. It was staggering. They so over-engineered them. They were so frightened about lawsuits and all the things that would come out of this, that when you buy these, you've got a battleship, they were totally impractical. You'd never be able to fly them again. So the rub is, you got to have the land.
So it's also the land and the cost then?
I don't think the cost is the problem. I think the FASCO ones, it was a cost problem because they did the own engineering and they didn't want to take any chances. But you know, the mobile home, that works. Why does it work? Because we can find sites, mainly we can find inexpensive sites for mobile homes. So that's the only truly manufactured home that has a huge market. And then the other ones, of course, the ones that we all love, the Airstreams, they're just beautiful pieces of industrial design. They're on wheels. So as long as you can roll them around and people will buy those, you have a market.
And we have the Airstream Trailer Show here in Palm Springs this weekend. Linda and Lance, both of you built in Pioneer Town where the land was inexpensive, relatively, and available for your prototypical houses. But there is potential for multiple. I mean, Linda, you're doing several houses now. Do you want to talk a little bit about that?
Well, I mean, I think Martin is right in saying that it's not really possible without the land. That's true. You have to have the land. We're doing a number of houses near where we built the prototype, but these are all financed by individuals. So each individual came and saw the house and thought, actually, this is perfect. This is exactly the kind of house I want, and the site is great. And we happen to know all of the neighbors in the area, so we could just say, oh, well, so-and-so down the road is selling his land, and so-and-so over there is selling his land. So we've had a kind of organic process where the houses have started to multiply, but only because individuals have decided they wanted to do it. I think on a larger scale, the It House is really not designed, let's say, for the mainstream audience. It's really not. It's more of a small market of people who tend to have, for some reason, all of our clients live down a 4-mile-long dead-end road at the end of, as far away as possible from civilization, in the middle of a beautiful natural landscape. But it is possible to have certain economies built in. So through the use of having our manufacturers, we have multiple manufacturers manufacturing the different components. So we could create a kind of competitive market. So we could get their prices down, and they know that we're going to make approximately 6 houses per year, and so they would like to have our business. So we don't have the Fordist economy of scale that you do with a car. A car, if you had to custom make it, would cost you $1 million. But with the house, you can have a higher quality product that has more intelligence than, let's say, conventional construction, stick-built wood framing, for example, that is at the same cost. So it's not so much the multiplication as it is the economy and quality that you can get with the new technology.
I think you're right. I think there's another part that we all thought back there in the 68s and 70s that the wage split, what you pay the guy in the field and what you pay him in a factory would be big enough to offset some of those costs. And that never happened. And the guy was a skill saw. The skill saw could cut wood so fast, and all the tract houses learned to partially prefabricate on sites, shipping it all out. And with the abundance of wood still, it was hard for steel to catch up. Now in Canada, they're way ahead of us. In Canada, they use the steel studs beautifully. And so there's very little wood framing. And there's a wonderful, Japan Architect 75 just came out that traces 50 years of steel building in Japan. And their first steel house is 1950, right after Eames. And today, 75% of housing in Japan is steel. Now, I did housing in China. I just designed it, didn't build it. I mean, we do 25, 35, 40,000 units. That's what you need, and the Chinese can do it. But they do it all in country. Steel, they're using steel in there. So they almost prefab in country.
Well, and how does that affect the Hamptons Modern project in terms of multiples?
Wow, that's a curveball. Yeah.
If they make it work, you can go.
Is there land?
Yeah.
Is there land? Do they have
There's land. Apparently Wall Street's doing well again. So yeah, time will tell. I was going to get back to just the idea of the blue sky home and where we're seeing potential. And I think Dave McAdams here, who lives in the Rock Ridge, hated. And so Dave's kind of spearheading what Linda was saying was this sort of organic growth of lots and these things popping up. So we have the second blue sky home going up right now. It's slightly larger. You know, it's 1,200 square feet, 1,250, as opposed to 1,000. And what we've sifted through over the last couple of years as we've tried to get this, you know, really off the ground is we've had a number of people coming to us with unbuildable lots in the Hollywood Hills, unbuildable lots on the coast, unbuildable lots just somewhere, and trying to solve the issues of the unbuildable lots. And where the affordability or unaffordability comes in is that now you're at a very remote site without electricity, without sewer or water. You know, then you're having to deal with all these systems in a way that you know, adds a huge level of cost to the bottom line.
Well, each of you have used either steel or aluminum in designing both your residential and commercial structures, and we really recognize the importance of precise detailing. And I know, Linda, you made some adjustments from your own house, from the first prototype of the It House to the second one that I saw up in Pioneer Town. Maybe you could talk about what you learned from one house to the other in terms of detailing.
Well, what's funny is we started out thinking that It House was going to be this kind of multipliable design, so it had a plan that we thought was perfect. And you know, the thing is, when we've got around to doing our own house, we became our own worst client and said, but we actually want to change everything. Let's move we want the kitchen over there. We don't really like it anymore. And so we were very mean to everyone else, saying like, no, you have to have the kitchen there. But for ourselves, we said, well, no, we don't want the kitchen there. We want it over here. So we started, the thing is that each prefabrication, people don't really want the same house over and over and over again. Everyone wants something different. Everyone wants to customize it. Everyone has a different piece of land, different neighbors, different lifestyles. So, you know, the detailing also relates to this issue of lifestyle and the way you want to, you have small houses, big houses. So every new house becomes a new opportunity for us to really re-engineer these details. And some of those details are improvements, like our house was slab on grade, and not to get into too much technicality, but we realized that the tolerances of concrete guys like to say, we'll get it within an inch. They don't like to say, we'll get it within a millimeter. So we found a way to make the Bosch system become the formwork for the concrete as opposed to the other way around, so that we could not have to make a trade that doesn't want to make something within a millimeter have to think about that at all. They simply, do their foundation and then we build it on top. So we're really kind of geeks about this, developing new details with new technologies or old technologies and finding ways in which you can join these systems. If that answers your question.
Yeah, that's great. No, and Land's also in Pioneer Town, the way you say the house sits lightly on the land. It's the siting that's so important with many of these challenging sites.
Well, yeah, I think absolutely that, you know, the multiple images that Barton showed of all the Seminole steel houses, I mean, those were all gorgeous sites. And I think if somebody's going to build something that is innovative, they already have an idea that, you know, it's going to be in, you know, some location that's just fabulous. And the great thing about the system is that it's, you know, it can float over anything. And it's just a matter of getting you know, small trucks and tools in there to do it. And so there's that aspect of the Blue Sky Home System, and there's also the aspect that once you get to multiple stories as well on an urban site, then it makes a lot of sense as well. So we can go up to 3 or 4 stories and virtually have, you know, no walls. We could you know, have the ground just carport, second floor glass, third floor, you know, and the sides could either be solid or glass, depending upon whether you're in a true infill site.
Speaking of infill, Barton, your house in Toronto, that was an infill, and you shocked the neighbors, didn't you? Do you want to talk a little bit about that project?
Well, we were known as the infill people there. I've always thought it was a great idea. It came out of Philadelphia, where generations of generations kept adding to the lots. And we did a lot of that in California too. It's a house behind a house kind of idea. And it's an amazing idea. You know, if you think, if every one of us in California could add one more unit to our lot, we could double the population and nobody would even notice. So that's what infill is about. It is urban consolidation, building on the fabric that you have, using the systems that you have, gradual intensification rather than radical intensification, and it has such a huge impact. So yeah, my house was the first sort of demonstration in the Yorkville area of a modern house. And it was a 25-foot lot. And the funny story is I was not going to do it in steel to begin with, and my engineer kept saying, well, Barton, you know, you got to prop these walls up, and I didn't want any interior walls. And he said, it's like a shoebox, it's going to fall over, why don't you use steel? And I said, great, can I afford it? And I turned to my cost consultants, and we figured out it was, yes, we could. So I had 4 steel wickets went up, and I had a little snow fence, and I drove by one night, and there was a crowd standing there looking at these 4 steel wickets, trying to figure out what was going to happen. To give Toronto credit, in most places, nobody is surprised what you're building. We go through more design review, public announcements. So in Toronto, everybody knew what I was going to build. There were committee hearings about the house and so forth. So there rarely is any surprise anymore. You know what's going to come. But it was kind of fun because I don't think they realized right away what they were going to get until they saw these 4 big wickets sitting on the site.
But you know, in Pioneer Town, where you both have built with Blue Skies and with the Yid House, there are some rather traditional houses and cabins and rather sort of primitive structures up there. Some of the locals must have thought, what is going on around here? What kind of reaction did you get when you first started out up there, Linda?
Well, I'm not going to lie. There were some people who thought it looked like a gas station. But, you know, I think it's to each his own. We actually are kind of nice in the area. It's so similar to Palm Springs in that there's a lot of experimentation. In the high desert, you have a much broader breadth of experimentation. So people are interested in building straw bale houses and container houses, or other unusual yurt structures, or cal earth houses. So you have a lot of people who are really into experimenting. And so I think for the most part, mostly people are really interested in seeing something that's done in a new way. And this was the reaction most of the time that we would get. The people were really intrigued by it. And I find that a lot of people within the community actually know of my house before I've even met them. So the house is more famous than I am. So
I love that. And Lance, when you were building your own house here and you were mounting all those boulders, I'm sure you had a few spectators in the neighborhood.
Well, yeah, the whole approach about the stepping the home with the natural children, which was 10 feet from the front to the back, and it really came out of a reaction that I saw over and over in my position as the Architecture Advisory Committee, where I would see one hillside home come in, and it's just a variation of a theme. How much can we bench this? How much fill can we bring in? How much can we raise this thing up till we're just at the, allowable limit? And when we approach the home, there's a million better ways to do this. I knew it intrinsically, and so I went to prove it on the site. And so it was just a matter of getting the home nestled into the site as seamlessly as possible. And the comments that we get, the best comments are, "I can't find your house."
I love that. That's great. Well, unfortunately, we are going to need to adjourn for our lunch break. But I really want to thank all of you. You're such innovators and so important to the field of architecture and the contributions you've all made to it. Thank you so much.